All right, 1.6, graphical transformations. All right, so basically with these, we're just talking about how it can be shifted. We're not actually graphing it. So if we have y is equal to x squared plus 5.2, this is outside the parentheses, quote unquote. So what does that mean is happening to this one?
It's a vertical translation.
Just tell me up, down, left, or right.
Up. It's like up.
Okay.
I'm
Up.
glad we all agree.
5.2. I was like, no. Just no.
Sorry.
I was like, those words are too confusing. Just
give me the numbers.
Too early.
for y is equal to, in parentheses, x minus 3 squared.
Right.
Right 3.
So is it only the opposite side if it's in parentheses?
Yep. Inside. Or what we're going to see in a minute when we get to one that has square roots is inside of a square root is considered left and right, and it's opposite the sign out, you know. So we treat a square root like we do a parentheses. 8, y equals, in parentheses, x plus 50 squared minus 279.
So
Right,
left
50.
50.
I mean, left 50 down 279.
Yep.
God, we're not graphing that.
Left 50 down 279.
I'm not counting by
10, y equals the square root of x minus 5. Right 5. And they don't have any like this, but if anything was outside of here, then we would be doing like up and down. And a negative on the x is going to be reflected. There's different ways that it reflects based on where it is, but just say that it's reflected. If you see a negative either out front of the whole, like the whole parentheses or the whole like square root, or if it's inside on the x, it would be reflected. 14, y equals 2x, and that's in parentheses, cubed. Yep. So if it is a number bigger than 1, okay, or negative 1, okay, because obviously the negative is only there to tell us that it's reflected. So if it's anything from negative infinity to negative 1 or 1 to infinity, it's stretched. And the way I've been telling people to remember is like obviously a decimal or a fraction, but those are closer in the alphabet to compressed. And so compressed and fraction or decimal, because this book's going to use decimals more. The Algebra 2 book uses fractions more commonly. So as I give you the answer to number 16, y is equal to 0.3 x cubed. So this one is, whoa, stop that. What happened? It's the second time that's happened today.
Notes at back.
It was like compressed, got it.
Got it. Say less.
All right, so these next ones, they give you two functions. They give you an f and g, and they want to know how to get from f to g. So what do we need to do to get from the first graph to the second one? So 18, they give us f of x is equal to, in parentheses, x minus 1 squared. And then g of x is negative, parentheses, x plus 3 squared. And so we're trying to get from f to g. So the way that I typically think about these is I almost write down underneath of each one what's happening. And then I say, okay, now what do I need to do to get from point A to point B, basically. So what's happening in f of x? Right 1. And then this is where?
Left 3.
And what else?
Reflected.
And it's reflected, yep. So now I was right 1, and now I need to get to left 3. So what do I need to do to get there? How do I move from right 1 to left 3?
Add
Go what direction and how many?
Left.
positive 4, I guess.
Left
Like
4.
putting stuff in there, you know.
So I need to go left 4. From this graph to this graph, I have to move 4 to the left. Okay. And then I also need to reflect it.
You asked what was going on in the first one. I was just gonna say x minus 1 is the squared. That is what is happening. Can't really say much else.
Now, there's weird things. So, like, number 20, I'm not going to do it because it's, like, the absolute value of 2x and then 4 absolute value of x. And so those are both stretches, but they're different kind of stretches because one's outside and one's inside. And so rather than trying to explain that I really wouldn't worry that much about, we're just going to skip that one. So just know it's whatever you need to do to get from the first one to the second one. So that's why I do it this way, so you can see, okay, I was at right 1 and I need to get over here, so I need to move back 4 in order to get there. So there's no more even examples, but anyways. None of the other ones that you'll have a like a stretch or a compression in them, so they'll just be like this one. So it wouldn't really benefit us to do the other one anyways. But there's vertical and horizontal stretches, and it's a little confusing to get from point A to point B, so we're not going to worry about it. Okay, now we're going to jump just a little bit. So we're modifying it slightly because this says to describe a basic graph and a sequence of transformations that can be used to produce a graph of the given function. So basically what they want us to do is to say what the basic function is and then explain from there how to get to the next thing. So what we're going to do is just explain what's happening. I trust that if it's in a square root, you know that it's a square root function, and then you can figure it out. So anyways, 44. Y is equal to -3 square root of x plus 1. So obviously this would be the square root of x would be the basic function that we're looking at. So what is happening to this graph then?
Left 1 reflected and stretched.
Left 1 reflected and stretched. Let's see, 46. Y is equal to -2, absolute value of x plus 4 plus 1. So what's happening with this one?
1, left 4, reflected, stretched.
Yep.
So absolute value also works the same way as like parentheses.
Yeah.
Okay.
Yep. Absolute value, square root, parentheses. I don't think there's any other ones that I can think of right now.
Brackets.
Technically, I mean, obviously with like sine and cosine, obviously that technically isn't a parentheses, but it would work the same way as well. if it was in there, but I don't think any of those are in this section. I don't see any, at least. All right, so the last ones give you the basic function, and then it tells you how it's getting shifted. And so I usually work piece by piece with these, and just keep rewriting the function. So 48 starts us with y is equal to x squared. And so I'm just going to go in order of what it says. Now, when it says like a stretch or a compression, I don't really care if you put it out front or if you put it directly in front of the variable. That's not something I'm going to take off for, because that gets to be a little confusing. I typically also, when we do a quiz or a test, will just say a stretch or a compression of whatever, if you have this type of question. So the first thing, so y'all just tell me what I need to change about the function. The first thing it says is a vertical stretch by a factor of 3.
Plus 3 again. Wait, a stretch? Oh.
Put a 3 in front of the x.
Yep. So y is equal to 3x squared. And then it says then, oh wait, hold on. Oh, I read this one backwards. I was reading the wrong problem. So it's just written back. It's fine. And then the other thing it says is a shift right 4 units.
So 3 parentheses x squared.
You're,
kind of there.
yeah, but the square needs to go on your parentheses.
Okay.
X minus 4.
X minus 4. Yep. And it's interesting because they try to confuse you a little bit, because technically the problem I just read you is actually 47. Even though, but the whole thing to say is order doesn't matter.
Yeah.
If it tells you to stretch it first, then shift it, or it tells you to shift it, then stretch it, it's not changing anything about it. So it doesn't matter what order. So those are actually going to end up being the same answer. It's just written in a different order.
So if we put 3 on the x in our final answer, then would that change the graph?
Yes. Because 3 would be getting squared at that point. Now, I'm not going to take off for it if you put it on the x, just because it gets confusing. Because this is the first time that you really are seeing there being 2 different kind of stretches. In the past, we've only done one type, and it's been attached to whatever the variable was. But they looked a little different. Because technically, where is it? Technically, vertical goes out front of the whole thing. Horizontal goes inside. But horizontal gets a little confusing by the way that you do it. Now, they call it a shrink. I call it a compression because I think it's easier to understand when you say compression. So if you see shrink in the back, know that means compression of the answers. I think horizontal gets to be a little more confusing by the way that you're technically supposed to write it, because it's technically supposed to be x over c, where c is the number that you're using. And so, like this next one that says it's a shrink by 1/2, I'll show you what it's saying, but I'll show you both ways. But
So is it
I just think it gets more confusing to do it that way.
So you're saying it's like a shrink of 2? Basically.
Kinda, yeah. So basically it starts us with y is equal to the absolute value of x. It says it's a shift left 2 units. So where's that going?
In absolute value, x, you say left,
Yeah,
x plus,
Yeah.
6, oh yeah.
2.
Oh, 2,
It was 2.
Okay.
And then a horizontal shrink by a factor of 1/2. I'm going to come back to that in just a second. And finally a shift down 4 units. So what does the down 4 do? Minus 4. So then the shrink by a factor of 1/2. So technically, Because it's horizontal, it needs to go inside. But if we converted it and we said that it was vertical, we would put it outside. So if we did this is vertical shrink or vertical compression. Okay, but that would be the modified equation. Unmodified, it would be, this is what it would technically be. Y is equal to the absolute value of x over 1/2 plus 2, which then becomes the absolute value of 2x plus 2, which no longer looks like a compression. And that's because it's kind of opposite. And I just think that that gets really confusing. So I typically tend to stay away from horizontal just because people get confused and end up writing the wrong thing. So more than likely, I'm going to give you vertical. And if you write it wrong, like you attach it to the X, I would say the general rule, just always put it out front. Now, if you want to try to understand all of that, you can, but it does change what the graph does, yes. But if you understand that it's a compression or it's a stretch, you should basically be fine. Because, again, you can graph them on your calculator if you really need to know what it actually looks like. I mean, most people don't understand what a vertical compression of 1/2 does to the graph. It's basically slope. So basically it brings it up 1, right 2, and so it widens the graph. Whereas a stretch is going to make it taller. It's going to stretch you up tall. So it would be like up 2, right 1 when you're graphing, like, say, an absolute value.
So is what in red, that's horizontal compression?
Yes.
Okay.
Yep, so this would be the... And this is actually, as the question is written, this should be the answer. Well, -4, I guess. That's actually what it should be, based on the way the question is written. So, it's not hard, it's just weird, and it tends to confuse people, which is why I tend to. Now, if it had been a horizontal stretch of, say, 2, it would have just been left as, like, x over 2, or 1/2 x. So, they're opposite what you would think for horizontal. Which is kind of like, you know, the opposite sign or the same sign for left and right or up and down. So, it's kind of the same thing, just, you know, whatever. Get my pages back in order here. All right, so your problems are 1, 7, 9, 13, 17, 43, and then 47 and 49, which we sort of already did 47. And 49 is very similar to 50. Well, actually, no, we didn't, I guess. I was going to say we technically just did 40 or 49, but we actually didn't because they changed it to vertical.